Hello friends, thanks for watching my YouTube channel. Um, Today in this video I'll be talking about how to check normality of a data, which is super important in data science and in statistics. Before we do a hypothesis testing for a parametric test, uh, most of the parametric tests rely on mathematical assumptions that the data follows normal distribution. But if we do not check properly our data, whether it follows normal distribution or not, whatever decisions that we might make can mislead. So it's always very important to check normality of the given data before we apply any parametric test. So checking normality is a fundamental step, I would say, because it determines whether you can safely use any given parametric statistical test or not. So today in this video I will be talking how to do that normality test and which are common methods to test the normality of a given data, so that you will be fully relaxed before you go for any parametric test such as t-test, ANOVA or linear regression, which highly assume that the given data set is normally distributed. Alright, thanks one more time. I will show you here. So the test that I will introduce here is Shapiro-Wilk test, which is very famous in data science and statistics. Shapiro-Wilk test basically gives you some idea about whether a given sample was drawn from normal distribution or not. I will grab an example here and I'll show you how to do this test step by step and how to do decisions based on p-value or the value of test statistic, which is generally represented by W. All right. So the test statistic is given as W. You can see formula there, which is called Shapiro-Wilk test statistic. This seems quite easy to remember, where Xi's are ordered random sample values, and AI are constant that can be estimated by using covariances, variances, and means of the sample size that was generally drawn from a normally distributed sample. But when you have a data set and you want to get some idea whether the given data set follows normally distributed or not, generally you don't need to apply this formula, because any platform that you're using might be skipping this part, because we're not going to do any manual calculations, but you still need to know what the formula is. So this W is basically Shapiro-Wilk test statistic. So when we will be doing hypothesis testing, the software automatically calculates the value of W and p-value for given alpha, and all we need to do is we need to make a good interpretation. Alright, so there might be some questions. Is there any alternative way to check whether given data follows normal distribution or not? And my answer is definitely yes. There are some visualization techniques by which you can decide whether your given data set follows normal distribution or not. For example, if you somehow get histograms or QQ plot, which generally gives you a rough idea whether a given data set follows normal distribution or not. For example, you can see here the first left hand side histogram seems normally distributed or closely follows normal distribution, and right hand side first QQ plot, most of the dot values are around this straight line. But the second one you can see is left skewed data, which is clearly shown by QQ plot as well, and third one is right skewed data. This can be also observed using QQ plot. But the problem with graphical representations are when data is close to normal, it purely subjective decision of the person, which one might assume, this is following normal distribution. Same time, other investigator, other researcher might say, no, it's not following normal distribution. So histogram QQ plots are really good as a thumb rule, but not especially when the data is close to normal distribution. Um, there are several other tests, Kolmogorov-Smirnov test and Anderson-Darling test. These tests can be also used to check normality. You can see how I did comparison between them. All right, the null hypothesis for this test is the population from which the sample is drawn is normally distributed. At the same time, alternative hypothesis is the population from which sample is drawn is not normally distributed. I have made my own calculator for Shapiro-Wilk test. You can use in R or SPSS or other software. You can try these softwares to check this test. At the end of this video, I will put R code and some SPSS methods, descriptions to make you easy how to do these tests using those softwares. Okay, so when you click on my calculator, you will see that sort of window where I simply copied and paste my data set. As I already told you, null hypothesis is data is normally distributed. Alternative is the data given is not normally distributed or not drawn from a normally distributed population. So we will first enter our data there, and then we will hit the button, run the test, and I will show you here what sort of output that we'll get, and then how it looks like. So once you enter your data set here, you can see here there are three different options. Either you upload an Excel file or simply copy or paste your data set here, which I did. And then you can, once you enter your data set, you can see here, you simply can go to different options that I will show you here. Look, run Shapiro-Wilk test, and then I will click there to get the values of P and W. You can see now when I click there and run Shapiro-Wilk test, I got value of W at 0.9717, and then P value is 0.90624. Since P value is more than 0.05, so my conclusion will be we need to we cannot say we reject null hypothesis because this is quite large value, so we need to stick with what we have in null hypothesis. So null hypothesis says data follows normally distributed, and we don't have that much evidence to reject our null, so we need to be stick with null hypothesis. Also, it gives you QQ plot as well. Now I'm going to change this test data set a little bit. Look what happens if I make this last observation 54 540, that is will work as an outlier. Now if I change another value 50.1 to 501 and run this test again, you'll see, look, this time the value of W is 0.3216 and P value is 0. So 0 means 0.00, which is very small. It's smaller than our level of significance alpha, that is 0.05. And you can see this time, since P value is quite low, we will reject our null hypothesis. So we can say that the data is not normally distributed. Thank you so much for watching this video. Please click my calculator. I will share the link on my YouTube video description, and you can do that by yourself. Thank you so much for watching.